Okay, we continue working with the example that involve exponent. Remember, I recall quickly when you multiplication, suppose x to the second power times x to the third power is x to the fifth power, and we confront this 5, 2 plus 3. Multiplication is addition, and the exponent environment, exponent word is addition. So division is subtraction. Division is subtraction. When you have the same base, it's x to the second. Where I come from this 2 is 4 minus 2. And when you have different level of the power, suppose like that, it's multiplication. Where I come from this 6, 3 times 2. So in this example, we are doing, okay, according to the order of operations, it's obvious that we are doing the exponent first. So it's x 8 over 3. Where I come from 8, 4 times 2. Okay, and remember how you multiplication fraction. Well, multiplication fraction is super easy. When you multiply 4/3 times 2, okay, 2 is a whole number, you multiply top, bottom. Okay? Okay, now in the bottom we have x. Let me check it out. The exponent is 3. 3 is a whole number. 3 over 1 times 5 over 3. If you multiply 3 times 5, 15. 1 times 3 is 3. And 15 divided by 3 is 5. I'll say another point of view is you cancel out that 3 and that 3 and stay only 5 over 1 gets just 5. So this is fifth power. This is fifth power. Okay, finally, division. And division is subtraction. Division is subtraction. So say basically you're subtracting 8 over 3 minus 5. Minus 5. Okay, 5 is a whole number. I suppose always, que the denominator is 1. The LCD is 3. En between 3 and, bueno, es 3. Entonces 8 minus, entonces es 3 times 5, 15. Ok, entonces minus 7 over 3. Ok, entonces the answer is, wow, it's x raised to the negative 7 over 3, pero never, we can express the final answer, never. It's illegal. Using negative exponent. It's no good. Now, I know, okay, I can't convert this negative exponent to positive exponent. How? Reciprocal. Okay, and this is the final answer. Final answer. Like the option C. Okay, super. Any question? What part you don't understand very well? Everything is clear or no? Clear? Okay, so now we start another topic, que is manipulation radical. Okay, let me try to explain the basic ideas. You know, for example, square root 25 is 5 because I discovered that 25 is 5 times 5. Because the idea for the square root is to find one number that multiply by itself. Give me the number inside the radical, que is 25 in this case. That's the reason. So the procedure that we apply is you break it down the number inside the radical and primary factorization, no? And each couple of factor you consider it like a one number outside the radical. Entonces in this case we have 2 5. Okay, entonces now 1 5 outside, and inside the radical we have nothing, que nothing is 1. The answer is 5. Okay, this is the idea. Let's practice this. Well, this is the case square root. And what about higher root? Suppose cubic. Suppose that we have 27. When you break it down, 27. 27 is no even number, but divisible by 3, yes, 3 and 3. And you see that we have, wow, look at that, 3, 3. And 3, 3 represent 1, 3 outside because we need 3, because the index is 3. Since 4 root, we need 4. And the answer is 3. And that's it. Suppose 4 root of the 16 maybe, right? You divide it by 2 is 8, divided by 2 is 4, divided by 2 is 2. Okay, we have 4 2, is exactly the amount of factor that we need to put outside like only 1. And the answer is 2. Well, the problem is, this is nice example, because by coincidence, we have exactly the same amount of factor that we need. Sometimes no. Sometimes not necessarily is super happy cases. Suppose that you have, for example, square root of 32. Okay, same procedure. Break it down in primary factorization. 16, 2, 8, 2, 4 to 2. But we are working with the square root. And the square root, you select 2 by 2. You select this couple of 2, represent outside 1, 2. This another couple of 2, represent another 2 outside the radical. And 2 times 2 together is 4. And stay totally inside the radical 2. This 2 is this 2. This is one point of view. Another point of view is, look, this is look like too long, professor. Okay, I understand. Another way, shortcut, is 32. You break it down in 2 and 16. And in this moment, stop. Because I detecting square root 16 is perfect square, F4. So this represents 1 4 outside. Let's see, we have 4 outside and stay 2 is this 2. It's another possibility. Don't worry, if you don't see this, no problem. You break it down totally, completed the number, okay, no problem. And select by couple. Each couple represents 1 factor outside. In the square root case, no? In the cubic root, you select 3 by 3, and the 4 root, you select 4 by 4. Do you understand the basic idea? Do you understand the basic idea? Okay, so you understand the basic idea. Let's move on. Yes, okay, Angelica is a yes. Let's move on to the, oh, let me try to erase that part. Let me try to apply this idea in the example of the practice. For example, let's doing 19. 19 say square root 252 x squared. This include a variable. Include number and variable, case x in that case. Okay. I don't care. You take 252 separately here. I copy and break it down. I know it's divisible by 2 because 252 ending in 2. Cuando ending in even number es even number. Entonces 126. 126. O sea, yo put in the calculator. 126 divided by 2 again because ending in 6, so it's divisible by 2. It's 63. 63 no, es not divisible by 2, pero es divisible by 3. The rule to divisible is 63. You adding 6 plus 3 and 9, and 9 is a number that belongs to the 3 multiplication table. You adding, you have big number, and you adding the digit. See, this result is divisible by 3. Of course, the big number is 63 is divisible by 3 also, no? Okay, this is the idea for the rule of the divisible by 3. Divisible by 2 is when the ending in even or 0. So 63 divided by 3 is 21. And 21, you know, is 3 and 7. Okay, now selection the couple. One couple of 2 represent 1, 2 outside. One couple of 3 represent 1, 3 outside. And this factor outside meet together and give me 2 times 3, no plus 3, a time, multiplication, a factor, is 6. The answer is 6. And stay inside the radical 7. That's 7, que es this 7. I feel no. Why no? Because we have x, que is a variable. But this is easy. So you have x squared. You can consider that x squared is x times x. This is, again, is a couple of x that represent 1x outside. It's a one point of view. Another point of view is easy. You divide the exponent, get 2, divided by the invisible 2. Here, we have in the index of the root, the 2 divided by 2 is 1. Boom. And this is the final answer. Okay, let me see. Selection. Is D. I guess so. Guys, if I make a mistake, let me know, right? Everyone understand the procedure? Good? Or complicated? It's easy. It's easy because you take the numerical part, break it down in primary factorization. Okay, let's move on to 20. 20 say, well, 20 is, look, is negative square root 180 K7 Q8. Okay, let's do it. Don't worry for this negative. This negative is the guy doing this practice put to confuse you. Pero no. This is like a negative 1. Entonces you don't touch. This negative you don't touch. Never touch. You keep it there. Entonces now I focus in the numerical part. 180. 180 is divisible by 2, of course, because ending in 0 is 90. 90 is divisible by 2, of course, because ending in 0 is 45. And 45 is divisible by 2, no, because ending in 5. It's divisible by 5. And also divisible by 3, because 4 plus 5 is 9. By 3. So I highly recommend it. When you are doing the factorization, you go in the same order and the same sequence of the prime number, get 2, 3, 5, 7, 11. This is 15. And 15 is 3 and 5. Okay, so I detecting 1 couple of 2, 1 couple of 3. This factor is 2 outside. The factor outside I put in the box. And 1, 3 outside. Okay, it's this couple. And 2 times 3 is 6. So the numerical part, and my problem is minus. Don't worry for the minus. You copy the minus. You copy 6 outside. You left some space here to the variable part. And inside the right, I know okay, we have 5. Yes, this 5. Okay. Now let's do in the variable part, one by one. K and Q. Well, K, we have 7. Entonces, I recommend que you try to break it down K7 using even number. Pero even number down, not up. O sea, no 8, sino 6. The MI, I consider K to the 6th power times K to the 1 power. 6 plus 1 is 7. I know que the even exponent, que es this. Bueno, it's easy. You divide 6 divided by this invisible 2, que is the index of the radical, is 3. Actually, we have K3 outside. We'll confront this 3, 6 divided by 2. And state 1K, que is this K, inside the radical. What about Q? I know Q is easy, because Q is even. Entonces, 8 divided by 2 is 4. So we have Q to the 4 power. And no Q inside, because it's even. And the couple is totally completed. We remain something. We have remaining part when there is odd. Like a 7, for example, no? Mentally, you break it down in 6 and 1. Okay, and this is my final answer. Okay, the option C. Guys, I need to feedback. Do you understand this or not? Complicated or easy? Normally, when I teach in that part, the student understand very well. The radical is easy for the students. The student understand very well the mechanism, the procedure. Okay, break it down, select the couple. Depending, no? Depending the index of the roots. Yes, cubic root, you select 3 by 3 and so on. Look at the next example. The next example is cubic root. So now, let me try. Okay, boom. Okay, delete. The second example say negative, again negative, I don't care this negative. I put in the final answer the negative, of course. But there's a cubic root, 125 x to the 4th power and y to the 5th power. Okay, I break it down, 125 divisible by 5, not by 2, not by 3. Because, you know, 1 plus 2 plus 5 is 8. 8 don't belong to the multiplication tree table. No. So it's divisible by 5, only by 5. And by 5 is 25. And 25 is 5 and 5. Wow, so we have exactly the amount of 5 that we need to go outside, only 1 5. The numerical part in this problem, I copy, minus 5, this 5, and inside the radical, we have nothing. Well, nothing numerical. We have variable, of course, x and y. But numerical no, because 125 is a number. It is exactly the amount of 5 we need to complete. This is perfect cubic number. Therefore, you factorization and unnecessary radical. Suppose we have no variable, the answer is negative 5, and that's it. Okay, now x to the 4th power. Well, x to the 4th power. Well, in this case, it's different because it's a cubic root. The index is 3. I try to find the exact multiple of 3 close to 4, get 3. So this is x to the 3rd power, then x to the 1 power. And the cubic root is x, 1x outside, and 1x stay inside, is this. And y to the 5th. Y to the 5th is similar, it's y to the cubic and y to the 2nd. This y to the cubic represents 1y outside, because 3 divided by 3 is 1, and y squared stay inside. It's important to understand, the power, the exponent, is smaller than, I forgot cubic root here, sorry. It's impossible go outside. only we can simplification if the exponent is greater than the index of the radical. In this case, the index of the radical 3 and the exponent is 5. Well, you can simplification. And the x part, the index is 3 and the exponent is 4. We can. But when the exponent is smaller than the index, we cannot simplification. The exponent here is 1 invisible, no more simplification, and 2, no more simplification. Okay, so let me checking. Negative 5, xy, I suppose que is this, no? I suppose que is this. Do you see or no? Let me make a zoom. Yeah. Okay. Not bad. Guys, everyone follow me? Please answer me. I understand, I don't understand. Okay, yes, Angelica, I understand. Okay, now 22nd. 22nd is cubic root negative 27 a to the a power b to the 5th power. Simplify this. Okay. I need to record something. I need to record before this. For example, when you have a negative something, any number, you don't touch this negative. Okay? When you have a inside the negative, look. Okay, this is no real solution. No real solution. Why not? Why not? Suppose we have square root negative 25. No solution. Why no solution? Because the potential candidate to be a solution is 5 or negative 5. However, if you multiply 5 times 5, positive of is positive 25. No negative 25 is exactly we need. And negative 5 multiplied by itself, again the same repetition is negative times negative positive, and never we get, at least in the real line, que is this line, okay, we have infinity, negative infinity, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So on this line, never you find solution for this. But this is when it's a square root or any root que is even index. However, when it's odd, another complete situation happens. Look. Specifically, this example is typical. Is cubic root of negative 27. It's negative 3. It's real, super real. Why? Because negative 3 times negative 3 times negative 3, 3 times, because it's cubic root. This indicate me the number of 3 or the number of the number you can multiply by itself is equal to negative 27. Because negative times negative positive and positive times negative again is negative 27. It's exactly the number that we have inside, and the answer is correct. But when the index is odd, always we have solution. Doesn't matter if the number inside is positive or negative. Now be careful because you see some problem que no solution. But no solution, at least in the real field. I promise in the chapter 5 we found the solution of this. Okay, entonces in the numerical part it's clear que es 3. It's negative 3, sorry. Totally outside the radical. What about a? A to the a power. I try to find the multiple of 3 close to 8. Down. 3, 6, 9 is 6. 6 and 2. Now you break it down a in 6 and 2. So 6 divided by 3 is 2, a squared outside. And inside the radical we have que by the way, cubic root is a to the second. And a to the second is impossible continue simplify because this exponent is smaller than 3. Okay, b to the fifth power. Bueno, es b to the third power. Remember, exact multiple of 3. That means 3, 6, 9, 12, and so on. Time b to the second. 3 plus 2 is 5. Entonces b, but outside we have only one b, because 3 divided by 3 is 1, and stay inside b squared. Is the answer. Okay, minus 3a squared b is the option A, of course. Of course, the option A. That one. Okay. Do you see or no? And likewise, when it's 4 root or 5th root, you select 5 by 5 or 4 by 4, depending on the index of the root. Suppose 23 is 4 root 81, 84. 81 is not divisible by 2, it's divisible by 3. Because look, 8 plus 1 is 9. And 9 belongs to the 3 multiplication table. It's 27, 27 is 3 and 9, and 3 and 3. Wow! We have exactly 4, 3. It's exactly the amount of 3 we need to simplify because it's 4 root. Look at that. It's 3 outside, nice. 3 outside. Inside the radical, I have no idea. No 1, no numerical part, no. It's, bueno, it's 1, no? Que 1, you know, it's invisible. And a to the 4th power, well, okay, a to the 4th power, 4 root of this is just a, by the same reason, no? A, so we have nothing in the radical. So you have nothing in the radical because you don't need to write the radical. And the answer is 3a, or just 3a, like that. Boom. Okay. Let's do in the last one. Let's do in the last one. Guy, I'm doing too fast or I'm doing good? All right, let me stop and try to get feedback. Okay, I'm doing too fast, I'm doing well. Everything is understandable so far or no? Good. I mean, who is that?
You understand.
Okay, super. Okay, super. Okay. Okay, 24. 24 is similar, but it's cubic root. 24 is cubic root. Cubic root 125. K 12. I don't know, I did before. I know, okay, 125 F5, the cubic root, no? It's F5. What about K? K is 12 divided by 4. K 4. Done. Okay, a final answer. And of course, positive, like the option D. Easy. Okay, now I want to combine several radicals. So far, we are working with the only one radical. Now we have 3, 2 radical. So what is the manipulation? Well, the manipulation is, look, the manipulation is, well, let me put an example, an easy example first, to explain the theoretical part. Okay, suppose we have, suppose we have 10 radical 2 plus 5 radical 2. Well, this is, you know, 15 radical 2. Where I come from? 15. Well, I can see que 2 is a common factor. You factor out. Open parentheses, you put 10 plus 5. And 10 plus 5 is 15, and we come back to this. So this situation is perfect valid when the radical is the same. If the radical is different, so we cannot do anything, nothing. Okay? No, we can do something, but no, depending on the problem. No? In this case, nothing, but in another case, you manipulate separately both radical expression, and maybe we get something is lighter, depending on the problem. Let's do in the problem. This is the basic idea, and this is suppose que es minus, it's the same. So what is the shortcut? I see, wow, it's the same radical, nice. So you take the coefficient, 10 minus 5, radical 2, that's it. This is the key idea in addition or subtraction. Okay, let's do it. The first problem say square root 2x plus 8 is square root 32x plus 4 square root 72x. Okay, so you take each radical one by one and you break it down. In this case, 2x prime, x is prime. No, I don't touch the first, not necessary. Simplify because it's a reducer in lowest term. But in this case, no. 32 divided by 2 is 16. Divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. Yeah, in detecting, look. One couple of 2, another couple of 2. This represents one factor 2 outside. This represents another factor 2 outside. And 2 times 2 is 4. And 4 go outside. Look at that. Bam, 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 bam. And meet with the 8. Okay, 8 at the beginning is stay. Stay there. Therefore, 4 times 8 is 32. Now, so far, my problem say radical 2x, que I don't touch, plus 32 radical something, and this 2, and this x. Okay, I can know simplification, 2x. You follow me? Now let's move on to the last one. The last one is 72. 72 is even. 72 divided by 2 is 36, no? Say 36 divided by 2 is 18. Divided by 2 is 9. Divided by 3 is 3. Again, we're detecting a couple of 2, a couple of 3, go outside like a 1, 2, go outside like a 1, 3, and 2 times 3 is 6, and 6 times 4, que is that factor outside, is 24, plus 24, radical something, I have no idea. Oh, these two stay inside, no couple, and x. Okay, entonces in this case, I can see que they are lighter because have the same radical. Entonces, si es the same radical, entonces you're adding 24 plus 32 is 6, and 5 is 56, right? But don't forget that we have 1 here, no? The 1 is 57. 57 what? The answer is 57. Bueno, 57 radical 57 radical 2x. End the story. This is the answer. Look at that. Here's the answer. Look at that. Here. Here's the answer. Do you understand? Too long? Complicated? Easy? Easy or no? Come on. Let's practice this. Several radical. Simplify. Assume que all variables represent positive real number. Simplify. Es the command. Simplify. Simplify. Okay, simplify. Always. What means simplify? Que you condensing this 3 radical in only 1. Simplify. Simplify. Okay. Let's move on to the next. 26. 26 is 6. 6 radical 48 x squared minus 2 radical 27 x squared minus 3 minus radical 3 x squared. Okay, this is 26 problem. Okay. Entonces, I know the procedure is always the same. You take numerical part, get 48, and break it down. Divided by 2 is 24. Divided by 2 is 12. Divided by 2 is 6. And 6 is 2 and 3. Wow. I detecting one cup of 2, another cup of 2. This represents 1, 2 outside. This represents another 2 outside. This one. And multiplication is 4. And 4 times 6 is 24. And let me copy 24. Radical something. And stay inside the radical that 3. Okay, don't participate in the selection of the couple. And what about the variable x squared? Ah, well, there's only one x outside. And this is the simplified form of the first guy. The second guy, 27 is obviously divisible by 3. It's 9, 3 and 3. Therefore, we have a couple of 3. This couple of 3 represents 1, 3 outside. And this 3 multiplied by negative 2 is negative 6. Negative 6, x again by the same reason, and stay inside this 3 case, by the way, is this 3. Minus, the last one, 3 is a prime, and we cannot do anything, but x, I put 1x outside and radical 3. Okay, you simplify one by one, and now you can see that they are lighter. This is 24 minus 6. Minus 6. Well, you borrow 1 and 14 is 8, 18, no? 18. We combine this and this. And don't forget here is negative 1. Minus 1 is 17. 17. Entonces the answer is 17x radical 3. I guess so. Let me see. The frequently mistake, the student making mistake is ignore this negative 1 here. Okay, because it's invisible. So I understand, but the answer is 17, x radical 3, like A option. Any question? No? Okay. Easy. Normally, when I teach in this algebra, the student, the radical part, understand very, very well. I suppose because it's easier, no? Another topic, factorization is complicated, but radical no. Radical no. Not complicated. Okay, 27 now. 27 is. Okay, 27 is 9 and 9, no? Yeah, and 9. And 9. Okay, it's 9. 4 root, wow, of x to the 7th power minus 4x square root 4x to the 3rd power. Well, in the first expression, I can simplify it because 7 is greater than 4. In the second, no, because 3 is less than 4. So that means that the second expression, we cannot do anything. However, in the second, yes, it's x to the 7 is x to the 4. Remember, I select exact multiple of 4, so 4, 8, 12, x to the 3rd power. Something like that. Now, these 4 go outside like a 2. Like a 2? No, like a 1. Because 4 divided by 4 is 1. So it's 9x radical 4 power, 4 index, x to the 3rd power. Minus 4 x 4 root x to the 3rd power. Yeah, I can see, wow, they are lighter because contain exactly the same variable, x, 1x outside and qb inside. So we can combine 9 minus 45. 5 what? 5x, 4 root x cubed. Done. Final answer. Okay, what's the option that I need to select? I need to select this one, A again. Okay, super. Super, super. Okay, let's do it one more. In that page, case 28, case 4, cubic root of A plus cubic root A. Simplify that. It's obvious. In this case, we cannot do anything. In this case, you can do, but you can do in the numerical part because A, the exponent is 1. This is smaller than 3. So I copy this because I cannot do anything in the first one. In the second, yes. And the second is cubic root of 8. 8, you know, 8. 8 is 2, 4, 2, 2. Okay, so we have exactly the amount of factors that we need to simplification get 3 because the index is 3. Entonces 2 cubic root of A alone because the numerical part completed go out because A is perfect cubic number. I know. Before the cubic root of A is 2. It's no surprise. Now you adding is 6. 4 plus 2 is 6 cubic root of A. It's the final answer. Let me check it out. Oh yes, it's this answer. It's this answer. It's this answer. Super. Any question, guy? Okay. Okay, now I want to go to the restroom now. They take 2 minutes. Okay, waiting for me, and we continue next page. Okay. Okay, I am back. Okay, I want to erase everything. Okay, now we have another page. Yeah, it's the practice test for the document. We are doing this. Yes, no? Okay, we are doing this. Let me select 2. It's possible to select 2 page. Insert. Okay, no. Okay. Let me delete this. Temporary. delete. Focus it in this. Well, this is similar. Is 29 is 2 cubic root of 27 x plus 2 cubic root 125 x. Well, this is easier because I know by memory that cubic root 25 is 3, and this 3 go outside, and 3 and 2 together is 6. X6 cubic root of x. Only that. The total and numerical part go outside like a 3. Now, exactly the same happened here. I know by memory that cubic root 125 is 5, and 5 times 2 is 10. Cubic root x. And we, inside the variable case x, we cannot do anything. Why? Because the exponent is 1. This is smaller than the index. No couple, no triplet, no nothing. So now we combine like term is 16. 16 cubic root of x is the final answer. I guess so. Now let me checking 16. Yeah, it's this one. Okay, let's move on to another. 30 say 9 cubic root m7 p5 fifth power minus 5 n squared p cubic root again and p squared. It's obvious in the second term, we cannot do anything because the exponent 1 is smaller than 3 and 2 is smaller than 3. So we cannot simplify anything in the second. In the third, yes. In the first, yes. The first is m to the 7th power. And remember, you break it down using exact multiple of 3, que is 6. Times n to the 1. And 6 divided by 3 is 2. So we have 9, bring down 9, m to the 2nd power. Where come from this 2? 6 divided by 3 is 2. Okay. And stay. Guess this. Likewise, p to the 5th power. You break plus 3 is p3 down p squared. Now 3 divided by 3 is 1, 1p outside, and stay p squared outside. Now I just copy that. Yeah, detecting is lighter. It's exactly the same variable, exactly the same exponent. You say use subtraction. 9 minus 5, 4. For what? M squared p radical and p squared. Finals. Wow, no. Okay. Let me selection. Yeah, SC. Look, SC. Super. Okay. Everyone follow me? So in this topic, we see 2, 3 radical expression. Use simplification one by one separately, one by one. And this problem is created in the last moment. They are lighter, and we combine. We can combine when you have same expression inside the radical. As you have different, no. But when they're the same, yes. Okay, now let's move on to the next topic is rationalize. Okay, this is Important word, rationalize mean Rationalize means eliminate any radical in the denominator. Suppose 31 gives 7 radical 2. Rationalize this expression. Okay. I take advantage of this property. Look, radical 2 times radical 2. When it's the same number, of course, it's different. No, it's 2. Wow, but why, professor? Bueno, okay, let me prove. Because it's radical 4, no? Because you multiply 2 times 2 is 4. And radical 4 is 2. In general, radical any number times radical any number, if the number is the same, is equal any without radical. So this is a fantastic way to eliminate radical. So if we create, look at that, we create here, this is my original problem. We create the smart one, que es radical 2, no? You know that any number or any expression divided by itself is 1. And this one doesn't affect my problem. So this is my original problem. However, I create here one smart one to help me to rationalize. This is the smart one. So you multiply 7 times radical 2 is 7 radical 2. And radical 2 times radical 2 is 2. And this is the answer. Answer after the rationalization. Okay, I repeat again, rationalization means eliminate the radical in the denominator. It's like illegal. Okay, when you have radical in the denominator, no good. It's B, the answer. It's B, the answer. Okay, let's practice rationalization. It's easy. Rationalization is eliminate the radical in the denominator, and the fantastic way to do that is multiply by the smart one. The smart one is formed by the repetition, the radical that we have actually in the denominator, and that's it. Okay, this is 32 is a little bit more complicated. Look, let me show you in detail. Pay attention, important. So I use simplification. 32 is minus. Remember, this minus is completely stupid minus because it's supposed to confuse you. 25 over 12. I need to simplify this expression and, of course, express it, the final answer, in rationalized way. Okay, let's do it. You copy negative here and I apply the property. Any fraction we can separate. Entonces I detecting que square root 25, 5, negative 5, nice. But 12 is not perfect square. But no problem, I break it down to 6, to 3. And I detecting a couple of 2. Okay, go outside like 1, 2, and inside stay 3. This 3 is this 3. Okay? And leave it like that? No. Why no? Because you need to express the final answer in rationalized way. Entonces now my recommendation is multiply by the smart one, que es radical 3, because I know que radical 3 times radical 3 is 3. Entonces in the top we have, okay, this is a fraction, another fraction, smart one. This is time, of course, the arithmetic operation. Now it's minus what? 5 radical 3. And look at that, radical 3 times radical 3 is 3. And 3 times 2 is 6. Oh, this is my elegant final answer. Let me show you. Yes, is C. Is C. Obviously is C. Is C. Everyone follow me? Good. Okay, no problem. Let's move on to the next one. Okay. Okay. Oh, next one is super easy. Is 33. 9 radical 5. Oh, this is easy. The smart one is radical 5, radical 5, radical 5. The answer then is 9 radical 5 divided by 5, because radical 5 times radical 5 is 5. Boom. Final answer is option 9 radical 5 over 5, A. Okay, 34, super easy. 9 radical 2. Multiply by radical 2, radical 2. 9 radical 2 over 2. Selection, 9 radical 2 over 2 is A. Wow, it's A. It's the same. Option. Beautiful. Okay, 35 and 36. This is a little bit more complicated. The reason it's a little bit more complicated is because we have two numbers inside the radical, not only one. Okay, it's square root 49 over 2. It's big mistake. Try to do the division first. No, you separate. Square root 49, square root 2. Square root 49 is 7. And we fit in? No. Why not? Because you need to express the final answer in rationalized way. 7 radical 2 over 2. Because radical 2 times radical 2 is 2. This option C. This option C. Now 36 is similar. Square root 50 over x. Well, in this case we have variable. Okay, it's the same. Is square root 50 over square root x. What about 50? Well, 50 divided by 2 is 25. And 25, 5 and 5. We have a couple 5 we need to simplify. Guess 1 5 outside. So definitely we have 5 radical 2 over radical x. Now the last moment is rationalize. In this case, radical x, radical x. Remember, this rule is valid not only for the numerical values, for the any expression. Say when it's a variable, but when it's numerical, it's numerical. So radical x times radical x is 1x. So we have, look, we can condense it. 5 radical 2x, because you put together in only one common radical over x. Done. Let me try. Let me see. Is 5 radical 2x over x is option D. Option D. Option D. Wow, I like that. I like the radical part. Okay. Let's move on to the last page, I suppose. Good, beautiful. Delete everything. Okay. Let me try to upload the last page of this practice for the test 4. Okay, this is the last one. Insert. Okay, this is the last one. Enlarge a little bit. Okay, this is another completely different idea. Look, let me show you in detail. Look. Okay, in this case, rationalize the denominator. Okay. So you have one expression. Look, 37 is 5 over 7 minus radical 2. And so I need to do something in order to rationalize. It's the idea, rationalize. Look, rationalize. In this case, different. Why is different? Because it's binomial. Look, 1, 2 guys. Entonces I understand very well when it's monomial. Suppose que 5 radical 2. Okay, it's easy. Multiply radical 2, radical 2. 5 radical 2 over 2. Oh, this is easy. But this is monomial. When it's binomial, it's completely different. Let me explain now. You create a smart one also. But this smart one is formed by the conjugate. Conjugate. This is a technical name, conjugate. What is the conjugate? The conjugate of 7 minus radical 2, que es our denominator, is 7 plus radical 2. So you change the sign. Okay, it's 7 minus radical 2. Minus no plus radical 2. And you divide and multiply by the same guy. This is my new smart one in the binomial. Conjugate, conjugate. Keep in mind this word, conjugate. What means conjugate? It's the same binomial. What is the conjugate? A plus B. The conjugate is A minus B. And when you multiply A plus B times A minus B, I know very well that the answer is A squared minus B squared. It's a special product. Okay? Normally, we are doing this formula in that direction, factorization. But we can do in opposite direction, multiplication. In this case, when you multiply here two expressions, they are conjugate, the shortcut to do fast is 7 times 7 is 49. Not necessarily apply FOIL. And minus radical 2 is 2. Radical 2 times radical 2 is 2. And always minus. Do you see the formula? Do you see the formula? This professor, oh, I don't like, I don't understand. Okay, no problem. Let's do it like a kindergarten guy. Look, 7 minus radical 2 times 7 plus radical 2. Well, I apply 40. 7 times 7, 49. 7 times radical 2 is plus 7 radical 2. This and this together is minus 7 radical 2. And this is radical 2 times radical 2 is 2. And always cancel out this and this. I guarantee you. Entonces we have, sorry, this is minus. Because negative times positive is minus. Okay, entonces what is the shortcut? What is the shortcut? It's the formula. What formula? That formula. Okay, you very well know. You are familiar with this formula. The formula says A plus B, A minus B, multiplication conjugate, is equal A squared minus B squared. The basic square the first. Okay, in our example is 7. 7 squared is 49. Square the second, que es radical 2 squared is just 2. O sea, es 49 minus 2, 47. So the expression at the denominator is 47. In the top, well, the top is easy because it's monomial. You multiply like that, like a distributive property. No, okay, you multiply. 5 times 7, 35. And be careful. This is the first time I explain this. When you multiply, for example, whole number, okay, 5, multiplication by radical 2, you consider it, okay, here we have invisible one. And you multiply this times this, que es 5 radical 2, plus 5 radical 2. What is the final answer then? The final answer is 5, no, 35, sorry, 35 plus 5 radicals 2. It's the answer. Okay. Like. Option C. Option C is my final answer. I need to explain more because maybe it's confusing. Okay. Look. Okay. Super. Okay. One extra explanation. Now, this is the first time that we're doing multiplication. Multiplication to monomial. Monomial can include different radical. Suppose que I multiply 5 radical 2 times 3 radical 5. Well, so you multiply only the number outside and the number inside separately, independent, because they are different category. 5 times 3, 15. And radical 2 times 5, 10. And we can simplification this a little bit more. Let me see, I don't know, I have no idea. 2 and 5, no couple, no simplification. This is the answer. But basically, when you multiply 5 times radical 2, you consider that the coefficients here is 1, and you multiply 5 times 1, get 5. And we have no radical here. So you consider que 1 times 2 radical 2. Okay, inside, outside. Different category, we cannot mix it. No, illegal. Outside, inside the multiplication of the monomial we use in radical. Okay, let's practice a little bit. Multiplication expression that contain different radicals. Suppose 38. 38 say, parenthesis radical 2, minus 6, close the parenthesis, multiplication radical 7, minus 4. Okay, let's do it. In this case, no special product, because the special product is when you have twin brother or conjugate. The conjugate is family. It's the same thing except it's opposite sign. But okay, in this case, no family. So you apply regular FOIL as always. First, radical 2 and radical 7 is radical 14. Radical 2 times negative 4 is minus 4 radical 2. Remember, there are no possibility to multiply number inside the radical and number without radical. This is minus 6 radical 7 is this. Outer and inner is positive 24. Boom. Okay, let me try to do my best. Multiplication, the simplification here is 2 and 7, no couple, no, don't say copy like that. Minus 4 radical 2, I know that 2 is prime, impossible. 7 is also prime, impossible, 24. And we can combine this radical, no. Why no? Because there are different numbers inside the radical. This is my final answer then. Is the option 14, okay, B, option B. Option B. Option B. Do you understand the idea? Unfortunately, si you have radical que contain different number or different expression, we cannot combine. What is the same? Yes. Okay. This is number 38. Example 38 was 39. Well, 39 is easy. It's 3 plus radical 2 squared. Okay, by the way, this is equivalent to write 3 plus radical 2 times 3 plus radical 2. They are twin brother. If you want, we can apply formula. Oh no, so you suppose you don't remember the formula for the twin brother, you apply FOIL again. 3 times 3 is 9. 3 times radical 2 is 3 radical 2. 3 times radical 2 is the same, I copy in this order. And radical 2 times radical 2, I know get 2. Okay, nice. So in this case, we have 9 and 2 together, is 11. So we combine lighter this and this, 11. Now, of course, this and this together gets 3 plus 3 gets 6. Radical 2. Boom. Final answer. 11 plus 6 radical 2. Big option. This one. Boom. Big option. Easy or complicated? Another possibility. Okay, I know that the students don't lie. But some students lie. This formula, a plus b squared, remember, is a squared plus twice ab plus b squared. In our example, we have 3 plus radical 2 squared. This is a square the first. The first is 3 squared plus 2 times multiplication both is 3 and radical 2 plus radical 2 squared. And this is 9. This is 6. And this is 2. And we get exactly the same result. 9 plus 2, 11. 6 radical 2. Boom. Same answer. Some people, I don't know why, don't like the formula. What's the reason that we have formula? Because we have two special product. What are the two special product? It's important that, okay, so you memorize this. Your algebra is more efficiency. The two special product is when you multiply any binomial, a plus b by itself, twin brother, que by the way is equivalent a plus b squared. And the formula is square root first, que es a squared, plus twice multiplication both, plus b squared. Okay, this is special product. We have another special, que es the conjugate. When you multiply any binomial time, is conjugate, que es a family, because it's the same expression but opposite sign. In this case, I know that the formula is a squared minus b squared. In both cases, in both scenarios, we can apply FOIL, always. FOIL is universal. But it's a little bit in I got there, right? It's for the student, beginner student. Oh, we apply FOIL. However, if you realize that you are in front the special product, when they are twin brother or family, you apply the formula and that's it. Okay? So it's up to you. Si you continue working using FOIL or you prefer the formulas. Okay. Boom. Let's move on to next. Next is okay. This is the again. This is 40. Que es paréntesis 3 minus 2 radical 3 square. Let's do it in both ways. Because little by little, maybe you make a decision to switch into the formulas. But okay. Suppose that I never memorize any formula. I have the multiplication two binomial, okay, they are twin brother. And you apply FOIL. FOIL is first, 3 times 3 is 9. 3 times this is 6. Remember, you multiply the number outside. That's 6 radical 3. Here, all we happen get the same. Is minus 6 radical 3. Where come from this 6? 2 times 3, no? And radical 3 is inside, I don't touch. And the last is plus, because negative times negative is positive, 4. And radical 3 times radical 3 is 3. Okay. Bueno, no, multiplication 4 times 3 is 12. So we have 9 minus 6 radical 3 minus 6 radical 3 again plus 12. Now 12 plus 9 is 21. 21, 11, yeah, 21. 21, and minus 6 together is minus 12 radical 3. Boom, final answer. Let me see, 21 minus 12. Let's see. This one. Let's see. Okay, another possibility using the formula. Let me try using the formula. The formula says this is equivalent, exactly the same. Square first, okay, 3 squared first, and minus, because this sign is minus. 2 times multiplication 3, que es the first, and b, que es the second, que es 2 radical 3. Plus, always plus in the second, square this guy, que es 2 radical 3 squared. Well, this is 9. This is 12 radical 3 because 2 times 3 is 6 times 2 is 12 and the square is 4. 4, 2 squared is 4, 2 squared is 4, and the radical, you know, is square root 3 square cancel out. The 2 and the radical is just 3. Entonces we have 12. You have 9. Okay, here. Let me copy here. 9 minus 12 radical 3 plus 12. Entonces in this moment we have, well, no. You combine, it's 21, no? 21, 9 plus 12 minus 12 radical 3. And you get exactly the same answer. I want to hear opinion. What way you like? Using FOIL anytime or using the formula? Honestly. There's no formula, okay? Yamin says, I like the formula because the formula is no, FOIL. Okay, Yamin believe gets much better FOIL. FOIL, okay. Another opinion, FOIL. Angelica is FOIL. Definitely FOIL. Okay. And the rest of the students, no? A ver, you. Dalida. No opinion. Okay. Alejandro is a foil. Okay, guys, I respect. This is the free country. Foil. Okay. Okay. I respect. Okay. So let's do it by foil. Always. No more formula. Okay. Moving on to 41. 41 is radical 6 plus 1 and radical 6 minus 1. Okay. Foil again because you like. However, I can see it's much better, in my opinion, no? Using the formula because I realized that they are conjugate. But okay. Foil. Radical 6 times radical 6 is 6. Radical 6 times negative 1 is minus radical 6. 1 times radical 6 is plus radical 6. And this together is minus 1. And this cancel always happen in the conjugate. And stay alive 6 minus 1 get 5. Wow, only one number. The answer is 5. The answer is 5. Okay, let's practice now. In the rest of the time that we have, let's practice rationalization binomial. Okay, so we have expression and we do something in order to eliminate the radical and the denominator. But when you have binomial, it's a little bit more complicated. Not a big deal, but a little bit more complicated. Suppose radical 5 divided by radical 11 plus 3. And the command say rationalize. The denominator assume okay. Rationalize. Remember, the idea is clear. Always the procedure is the same. You create one smart one is formed by the conjugate of the expression in the denominator, like that. This is our smart one. Okay, you know, when you multiply any expression original, this is the original problem, original, multiply by one, smart one, it's one, but it's smart, It's smart porque help me to simplification, no? Now, this is the organization. Original and smart. Okay. Now, I know that you like foil. Well, in the top, no foil. In the top is monomial and binomial. So you distribute it. Multiplication this and this, and multiplication this and this. In this case, radical 55, because the number outside, I suppose default is 1. The 1 times 1 is 1, it's invisible 1 here, but I don't like to write this one. And multiplication, the second is minus 3 radical 5. Remember, we cannot mix the number outside and inside the radical. 5 is inside, 3 is outside, you put together, but no mix it, no get married, no. Okay, we finish the top part. The bottom part, well, again, foil. Radical 11 times radical 11 is 11 without radical. Radical 11 times minus 3 is minus 3 radical 11. Positive 3 times 11 is positive 3 radical 11. And 3 times negative 3 is negative 9. As always happens, when you multiply a conjugate, that part can contain radical is cancelled. And this is the key idea of the rationalization. That is the reason that we are doing rationalization. Disappear, magically, disappear the radical part. And the top stay square root 55 minus 3 radical 5. And the bottom 11 minus 2 minus 9 is 2. Boom. Boom. Let me see. Is, well, it's the B option, no? B option. B option. Okay, in this case we cannot do anything more because we have radical 5 and radical 55, which we cannot do anything. So you, to make sure it is the final answer, you check in the choice that we have, no? You found, wow, nice. I stop. I got it. 43. 43 is 5 minus radical 2 over 5 plus radical 2. Exactly the same procedure. You create the smart one. How? Well, you copy the conjugate of the denominator. Is this. And this by coincidence. In the top part, they are twin brothers. But it's okay. And you apply 2 times 4 because you like 4. 5 times 5, 25. 5 times radical minus radical 2 is minus 5 radical 2. In this case, is again minus 5 radical 2. And making sense because they are twin brothers, it's this repetition, and it's a plus because negative times negative is the last multiplication 2. Entonces, let's continue manipulation the top part. Okay. I see que es 27, 25 plus 2 is 27 minus 10 because negative 5 and negative 5 together radical 2. Stop. And the top is okay. Let's move on to the bottom. Okay, magically, I suppose que disappears the radical. Foil. 5 times 5, 25. 5 times negative radical 2 is minus 5 radical 2. So far it's similar. But this case is positive, no negative. The reason is conjugate, not twin brother. Plus 5 radical 2. And finally is minus 2. Because radical 2 times radical 2 is 2, and plus and minus times minus is minus. So when you combine like that, 25 and minus 2 is 23, 23, and this cancel out. Entonces this is the answer, right? You put it 23, not exactly here, because I expect we have more, but no, it's okay. 23, you put in the middle here, 23. Boom, boom, boom. Final answer. Let me see. Let me check it. Check it. 23, 23. Oh, yes. Pero es minus, so it's A again. A option. A option. Here, over there. Over there. Okay, super. No big deal. Opinion? I know, okay, always foil work. You need to only remember one rule, foil, and that's it. Okay, let's move on to 44. Radical 7 over 7 radical 6 minus radical 7. Same thing. Okay, you multiply by conjugate. A conjugate is exactly the same binomial, but in the bottom is 7 radical 6 plus. You multiply in the top and the bottom by the same to create the smart one. And you foil. Let's doing the top part first, because it's easier. You multiply this times this. Let me try time 7 radical 6. I consider that the coefficient here is 1, and you multiply 7 radical 42. We're going from 42, 7 times 6. Entonces, so far in the top we have 7 radical 42, and now multiplication this. Radical 7 times, I know que 7, radical 7 times radical 7 is 7. Plus 7, no? Plus 7. Done. I did that. Going on to the Caesar. Bottom is conjugate. And the conjugate, well, I apply 4 again. It's this time this, be careful, is 7 radical 6 times 7 radical 6 is 7 times 7 is 49. As radical 6 times radical 6 is 6. You put in the calculator, 49 times 6. 49 times 6. Okay, 294. 294 was the first multiplication, foil. Outer. Bueno, outer is 7 radical 6 times radical 7. I suppose que the coefficient here is 1, entonces 7 radical 42. Pero positive. Entonces plus 7 radical 42. Inner, again, is negative 7 by the same reason, radical 42. This is a reason that this is cancelled out, and this is the process of the rationalization. And finally, minus 7. Minus 7. Because radical 7 times radical 7 is 7, and negative and positive together is negative. So now we combine 294 minus is 284. So far, the answer is 7 radical 42 plus 7 divided by 287. Well, I suppose my intuition say, okay, we can simplification a little bit more, because 287 is divisible by 7. Let me try my calculator. Divided by 7. Oh, it's 41, yes. Okay, good. I detecting in my calculator, okay, this is 7 and 41, no? And of course, we factor out 7, it's a great common factor. radical 42 plus 1. In the bottom, we have 287, gets 7 and 41. It's equivalent. And this 7 is cancelled. And what is my final answer? My final answer is square root 42 plus 1 divided by 41. I suppose. Let me try to see in the options. There's radical 42 plus 1 over 41. It's the option D, yes. It's the option D. Wow. Wow, amazing. Guys, you have to practice that part. And Alice, I prepare for you the homework. It contains that part, rationalization. And remember rationalization, when you have binomial, you multiply and divide. You create the smart one, multiply and divide by the conjugate. Okay? This is the last page for the practice. So we are ready to start a little bit, not too much, the review. Okay, let me try. Review. I suppose review for the test 4. Boom. Review include another thing. Look. Boom. Okay. Let me try to understand the review. Review bring me new thing. Okay, that's it. In the review, the first page say, determine the value that make rational expression undefined. What means that? Undefined means you have rational expression. Rational expression is division to two expressions. Okay, suppose expression 1 divided by expression 2. It's a rational. It's definition, rational is division to expression. And to be undefined means, well, the only possibility to be undefined is when expression in the bottom is 0. When expression in the bottom is 0, automatically you have something divided by 0, and division by 0 is totally illegal. Entonces, declararla que undefined. Okay, now the only thing you should do is take, in the example 1, the expression is x minus 9 divided by 4 minus x. You ignore totally that part. It's not important. Don't participate in this game. And you take the bottom part, expression 2, is 4 minus x. You enforce it to be equal to 0 and solve for x. Es obvio que I move this 4 is equal to x. And this is the answer. The answer is determine the value is 4. Likewise, in the second example, it's a little bit more complicated. It's x squared minus 4x minus 45 divided by x squared, no? Minus 9. Entonces you ignore totally the top part. Don't participate in this game to be undefined. The only possibility to be undefined is that the expression in the denominator is 0. Entonces I enforce it. X squared minus 9 equal to 0. Oh, but this is quadratic equation. And the example 1 was linear equation. Therefore, we have one solution. In this case, you expect 2 solutions. Why 2 solutions? Because it's quadratic equation. So your factorization here, like a difference of square is x 33 plus or minus. So I use it one more time, that formula. And the correct sense that we are doing so far is factorization. And now you apply the zero factor property. When the 2 factor is equal to 0, it's because the first factor is 0 or the second factor is 0. That means that one solution is negative 3 and another solution is positive 3. And we have 2 values to be undefined. This rational expression, positive 3 and negative 3. Doesn't matter the order, undefined. Super, do you follow me? So I never explained this part. It's the first time I explain, determine, but no. Actually, I explained when we compute the restriction. Remember restriction? Restriction is the value of the zero of the least common denominator. It's the same idea. It's the same idea. Okay. Let's move on to the number 3 and number 4. I don't know if we have time to 2. Let's do number 3. Okay, number 3 say identify. Okay, good. Solving. It's equation. Entonces, how do you know que es equation? Bueno, it's equation because we have equal sign. Entonces, look at the instruction. Identify least common denominator of the equation. Multiply both sides for the equation for the least common denominator. Solving and checking the solution. Okay, exactly the same procedure. Okay. LCD es obvio. Que es 7 times x plus 5. According to this LCD, the restriction associated with the equation is -5. Illegal. -5 is illegal. Okay, and you multiply whole thing by the LCD. Let's do it. It's 7 x minus 5, x plus 5, sorry. 7 x plus 5 and 7 x plus 5. Okay, this cancel out. And let's take 7 times 6 is 42 minus, this cancel out again, is 56 is equal, and this 7 is cancel out and stay 4 times x plus 5. And this is my new equation that always is easier than the original. Entonces 42 minus 56, I put in the calculator, is -14. And -14 is equal, you distribute the property here, why not? 4x plus 20. You solve for x, minus 14 minus 20 equal 4x. And it's a -34 equal 4x. Now finally divided by 4 both sides. And 34 divided by 4 is 17 over 2, no? X. After the, well, actually it's -34 divided by 4, no? But we can reduce in lowest term because I know that 34 is 2 times 17 and this is 2 times 2. We cancel out the greater common factor, get 2 and stay 17 over 2. And this is the value. And our value have no any coincidence with the restriction. The restriction, remember, is this guy, -5. Therefore, this solution is perfect. The answer is -17 over 2. That's the final answer for this equation. Okay, stop. Friday, we continue review. Remember, today at midnight is due the test on paper number 3 and test online in Alex number 3. Okay, remember submit because tomorrow in the morning I want to grade that. Okay, super. Wait. Okay, time is over. Therefore, I